Welcome. So in this lesson, we're going to be talking about graphs of exponential functions. So let's give this a read. An exponential function is one in which the variable is in the exponent. So as you can see here, the variable is my x and it's in the exponent position. The most basic exponential functions are of the form this right here. So let's just have a look at what this looks like. We are going to be drawing them by hand, but just as we're starting off here, let's just use our CAS to get a sense of what this looks like. So let me go 2 raised to the x. And if I do that, I'm going to get a graph that has this form right here. So it's growing exponentially. And we can change what our a value is going to be, and that will slightly change what this looks like. So maybe I make it go to be 5. So what's 5 raised to the x? And as you can see, you still got this shape here, but of course I'm affecting the dilation factor. So that's the basic shape that an exponential graph takes. But now we just need to spend a moment talking about what are my possible values for the base, so the a value. So in order to get this basic graph out, so in order to get this basic looking exponential graph out, there are some restrictions placed upon what the a can be. So the a is a positive real number other than 1, and the way that we write this is that a is an element of all real positive numbers excluding 1. Now, it's important for you to know that the reason why this is true is because if it was a negative number or if it was 1, we're not going to get a basic looking exponential graph out. Mathematically, it still works, but we're not going to get a graph that looks like this. Now, I'm going to go through both of these scenarios, in which case a is equal to 1 and a is less than negative 1. Sorry, a is a negative number, but you don't have to write them down. So I'm going to come over here just to kind of explore this. But I'm going to say don't write this down. You can if you want, but don't write this down. Okay, don't write this down. All right, let's explore both of these scenarios. So what I'm saying is if I let a be equal to 1, it's not going to give me a graph out that looks like this. Let's see if that's the case. So if I let a be equal to 1, that means I'm putting 1 into this a spot here. So it means I'm going to get y is equal to 1 to the power of x. Now let's have a look to see what would happen in this scenario. So let's come here, let's go there. Okay, let's begin by just plugging in values for x. So what if I was to let x be equal to 0? What's 1 raised to the 0? It's 1. So that means it would be there. What if I let x be equal to 1? 1 raised to the 1 is 1. What if I let x be equal to 10? 1 raised to the 10 is 1. What if I let my x be a negative number? What if I let it be negative 5? Well, that's the same thing as 1 on 5, which is just 1. Do you see that if my base is 1, I'm simply going to get a horizontal line? And that is why a cannot be equal to 1. You're not going to get that customary basic exponential graph. All right, let's now explore the second one. So that's the first bit, why it's excluding 1. But why can it only be positive numbers? Well, let's explore what would happen if it was a negative number. So that would mean that a is less than 1. A is less than 1. Let's see what happens in this scenario. So let's make it so that my base is negative 2. Let's see what happens when we plug in values of x in this scenario here. So let's come over here and let's start plugging in some values to x. What if I was to let x be equal to 0? Well, I'm going to get 1 out. No big surprises there. What if I was to let x be equal to 1? Well, I'm going to get negative 2 out. So when I put 1 in, I get negative 2 out. What if I was to put in into my x spot 2? Well, do you see how it's negative 2 times negative 2? That's going to be positive 4. So I got 1, negative 2. Now I'm getting positive 4. So that means when I put 2 in, I'm getting negative 4 out. You can already see that I'm not getting the basic shape here. Let's continue on. What if I was to put in x being equal to 3? Well, that means I would get negative 2 times negative 2 times negative 2. And that's going to be negative 2 times negative 2 is positive 4 times negative 2 is negative 8. So that means now when I put 3 in, I'm down here. Hopefully you can see what's happening here. This thing is oscillating and it's going to keep on oscillating like this. Now, mathematically, that's fine. But do you see how that when a is equal to 1, or if a is a negative number, I'm not getting out the basic exponential form. And that's what we're saying here. That's why we're giving this restriction here. A has to be a positive number other than 1. We can actually sketch this one on our graph. It's actually kind of fun to do it. If I was to put in negative 2 brackets raised to the x, whoops, that's not a negative. Whoa, sorry, whoop. Let's try that again. If I was to put in -2 raised to the x, what do I get out? Bang. Whoa. See how it's oscillating? And that definitely doesn't take the form that we want. It's kind of cool to look at, but... Okay, so that's how I just wanted to start off this lesson, by talking about that. You didn't have to write any of that down, so don't write this down. If you wanted to, you could have. But now we're going to actually get into the notes. So I'll pause here and then we'll continue on.